Quick video report on test number 4. Once again, the solids accumulated. We were only running at 2000 RPM, so they're not very solid. They don't have very good high stiffness. So, but anyway, solids were coming back out the clarified fluid port. You can see how much solid material is in the tube there. And so first of all, the material was not actually being centrifuged very well, I think. Although we'll still have to open it up and have a look inside. But secondly, it was the difference in height between the solids outlet port and the liquids outlet port are not really enough. I mean, rather, it's too large. It's not suitable. Anyway, so looks like the properties of the material and the RPM and the centrifugal force and the way the screw tends to mix up the material again, because these drivers are not capable of maintaining a precise RPM differential. It's either too high or it's too low, and they're not capable of really applying adequate force to regulate the speed. What happens is that the solids material gets sort of mixed back up again into the liquids, and then it comes back to the liquids port, or it just sort of forms a cake and jams the screw and barrel together, so they're kind of locked, and so they can't come out the solids outlet port because the screw is not turning relative to the barrel. So there's a number of bottlenecks. This motor coupler 2 is going to slip sooner or later. It's not clear how much torque it can handle, if it can handle enough torque to overcome the stiffness of the solid material, especially when the solid material is stiff enough to come out the solids port. So there's a number of different parameters that need to be balanced before we're going to get continuous operation with solids coming out the solids port. And there's some bottlenecks. Most likely this coupler here was going to slip if we do get enough torque, although it's not clear. If we had the photocoupler installed, the photo interrupter rather, then we would know whether or not that coupler was slipping, because the rod would not turn at the same speed as the motor. But we don't have that installed right now, so we can't really monitor that. At least the screw is no longer slipping inside the tube is no longer slipping inside the screw, because we epoxied them together, so that's fine. That worked out well. And we definitely want a shield on this motor, because every time it stops, a lot of splashing occurs and it makes quite a mess. From now on, I should probably keep the cover on the cover on there. There is a cover that goes on there. And we should keep the solids collector in place if we use it again. So this is the material we were pumping through it. You can see it's got a pretty high solids content. You can see some accumulates over there. It's like sort of sludge actually. And so that was able to fill up the solids dead volume fairly well without taking an inordinate amount of time. There's a slight tendency to clog the pump, but I only had to unclog it once during the test run, which was about 15 minutes long. So that's not too bad. So the pump can handle reasonably high solids loading. And probably the reason it clogged was because I added some potassium sorbate, and the potassium sorbate granules did not dissolve. You can see I don't know if you can see them there, little white dots. And so I got little granules in the pump. That's probably what clogged the pump actually. So where to from here? Well, fundamentally, it's clear that centrifuging this material is not really the best approach. Also, this design is got a couple flaws, which is all part of the process. We learned that. It would have been nice to have somebody on board who already knew that, but we didn't, so we went ahead and made things. It runs smoothly, it runs for long time periods, it runs without overheating or other complications and factors. We can dismantle it and put it back together many, many times. We've got a lot of stuff that worked well, but the most fundamental problem is that intersection between the solidity of the material the torque required to turn the screw, the height differential between the solids and liquid outlet port, and that's so yeah, those factors have to be balanced just right. Right now, they're kind of a little bit out of balance in a number of different ways. We might be able to bring them into balance, and then we would get some solids out. However, that would take some significant amount of additional work. It's not clear if we're going to have time to do that.